This problem and all other Calc 135 problems can be found in Sarai Studies. Link is in the description box below. Indeterminate limits is when you solve for a limit and you get 0 over 0. In our algebra brains, we call this undefined, but that's not an acceptable answer in calculus. In calculus, we call this indeterminate form because we're not able to determine what the limit is now, but we can. How can we do that? Well, when we see 0 over 0, that's just a fancy way of saying, hey, do some more algebra, and you'll be able to find the limit. In other words, simplify. So in this case, remember our number one tool is always direct substitution, where we directly substitute our b value. So whatever value here is always our b value. So that's -5. Wherever we see x. -5 plus 5, that's 0. This is 25. This is -20. This is 5. This together is -25. 25 minus 25, that's also 0. So we have 0 over 0. That's our indeterminate form. This means that direct substitution method failed because it didn't give us an actual limit. And so direct substitution method will always fail if our b value, when we plug it into our function, makes it undefined. And we can just take a look at this, right? Back in pre-calc, how do we know what makes it undefined? We'll set denominator equal to 0, solve for x is equal to -5, makes this function undefined because it makes the denominator 0 and we can't have that. So direct substitution will always fail when we have something, our b, that when we plug it in, it becomes undefined. But the thing is, when we have 0 over 0, that's just a fancy way of saying, hey, do some more algebra, simplify this, and you'll be able to get rid of what makes the function undefined, because all you care about really is the limit as the x values approach -5, not what the function is at -5. So our number two tool is to simply do some more algebra, or simplify. So this here we can factor. We can do product and sum method, so two numbers that multiply to a times c, and two numbers that add to b. So remember, ax squared plus bx plus c. So a is 1 times c is -5, so just -5. And then b is our 4. So two numbers that multiply to -5 and add to 4, 1 and 5, 1 and 5. And then how can I get it to 4? I make this a negative. And so this also has to be a negative. And so then we just do x, and then just take this number, positive 5, and that's this, but in factored form. This is x minus 1, x plus 5. And then at the bottom we have x plus 5. And then we can cancel these out. And then we're just left with the limit as x approaches -5 of x minus 1. And so now we can go back again and do direct substitution and directly substitute our b value. So now that we're directly substituting again, we don't have to write the limit. So it's just going to be -5 minus 1, that's -6, and that is our limit. We were able to determine our limit by just simplifying the function and getting rid of what made the function undefined in the first place, which was this over here. Now, as a visual representation of what's happening, this line over here is our function x minus 1. It is literally this, but just simplified. It's the exact same thing. So this is our f of x, and that's x minus 1. Now, when you plug in -5, what is our f at -5? What is our y value? It doesn't exist. It's undefined because it's an open circle. But just because our function at our b value does not exist, it's undefined there, doesn't mean that the limit doesn't exist as well. It does, because look, as the x values get closer and closer to -5, from the left side, what's happening to our y values? They're getting closer and closer to -6. We're being limited to being -6. As the x values get closer and closer to -5 from the right side, what's happening to the y values? They're also going towards -6. So the limit exists. The value will never be -6 because it's undefined there. But the y values are being limited to -6. They're approaching -6, which is why our limit is -6. We just happen to algebraically cancel out what makes it undefined, so we could just look at the limit. Because we don't care what it is at -5, we just care about the limit.